So now let's talk about electronic configuration. So now what is electronic configuration? Electronic configuration means distribution of electrons in subshells or orbitals, and we have talked that what are orbitals. Orbitals are the region of the space around the nucleus where the probability density of an electron is highest, or you can say almost 90%, right? So what is electronic configuration? Electronic configuration actually shows you the distribution of electron in a subshell or an orbital. So now let us find the electronic configuration with some exceptions too. For example, if I want to find the electronic configuration of hydrogen, we know that atomic number of hydrogen is 1, right? So it will be 1s1. If I want to find the electronic configuration of aluminium, so the atomic number of aluminium is 13, right? 1s2, 2s2, 2p, 2, 4, 4, 6, 7, 8, 9, 10, 3s1. So this is the configuration of aluminium, right? So let's make orbitals too. Here it is clockwise, anti-clockwise, clockwise, anti-clockwise. This is 1, 2, px, py, and pz, clockwise, right? And this is okay. So now let's just find the electronic configuration of chlorine, right? And the atomic number of chlorine is 17. 1s2, 2s2, 2p6, 3s2, 3p, 6, 8, 8, 10, 11, 12, 3p, 5. Okay, so now make the orbitals of p. According to Hund's rule, we will first fill one by one, right? Then one. So this is px, py, and pz. So the valency of chlorine is -1 because you can say the capability power, or you can say valency. So the valency of chlorine is -1 because it can accept one electron and can complete its octet, or you can say it can complete its orbitals, right? So let's find the electronic configuration of potassium, which is 19, right? The atomic number of potassium is 19. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, right? 6, 7, 8, 9, 10, 11, 12, 12 plus 16 is 18, and it's 19, right? Okay, if you are wondering that why I haven't put 3d10 first, so that for that you need to look my n+l video, which is like we will organize the subshells or orbitals according to the energy level. So the first lowest energy orbital will come, which was given by Aufbau. I will also try to make video on n+l rule and Aufbau. Okay, so now let's talk about calcium, whose atomic number is 20, right? So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, so now let's talk about scandium. Atomic number is 21, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1 will come here. Now let's talk about orbitals of d. 1, 2, 3, 4. Only this will come in 3. Okay, now we are having scandium, then we are having titanium, right? Titanium, whose atomic number is 22. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2. Make the orbitals 1, 2, 3, 4, 2, 3, 4. 1, and this will be the electronic configuration of titanium. Then we are having vanadium, whose atomic number is 23. Don't think that it's boring, it's quite interesting, and here one exception will also come, not in vanadium but in chromium, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. Okay, let's make our vitals 1, 2, 3, 4. Okay, now let's talk about chromium, whose atomic number is 24, right? Chromium 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d4. You will be wondering that this is the correct electronic configuration of chromium, but this is not. There is an exception. The another name of chemistry is exception, exception, and exception. Okay, so the correct electronic configuration over here will be 4s1, 3d5. Why? Like, why it happened? Okay, let's talk about stability. Stability only comes when the orbital is either half filled or fully filled. So the stability only comes when the orbital is either half filled or fully filled. As you can see over here, this is fully filled, right? But this is not fully, it is not half filled too. Here, this is like this. It is 1, 2, 3, 4. This is like this. And the S1 is, it means this is stable, but it is not stable too. So what actually happened, that this electron moves to here in order to give stability to both. As you can see over here, now this is half filled and this is half filled too. 1, 2, 3, 4, 5. And what we discussed previously, that the stability only comes when it is half filled either, or it is fully filled. So stability comes. Now you'll be wondering that why the electron actually moves, like how it can move from 4s2 to 3d. Okay, now let's talk about energy, like energy. We know that we can find energy by N plus L rule, like N, which shows the principal quantum number, and L shows the azimuthal quantum number, right? So over here you can see, talk about 4s and 3d, right? 4s0, 3 plus d, s0, p is equals to 1 and d is equals to 2. So it is 5, right? 2. 3 plus 2 is equals to 5 and 4. So, and what Afbahu actually said? He said that orbital or subshell with lower energy level will come first, and the subshell with high energy level will come after that. So as you can see over here, 4s is having less energy, but you can see there's difference, but difference is very slightly difference. So electron can move from 4 orbital, 4 shell to 3 shell in order to give stability, because there is only a slight difference. What's the difference between 4 and 5? Only 1 is different, so it can easily move. So stability comes when it is half filled or either fully filled. So there is an exception in chromium that we don't put 4s2 3d4, but we put 4s1 3d5 in order to give stability to the atom of chromium. And why the electron moves? Because of the slightly difference in the energy. Now let's talk about other electronic configuration. There is another exception, which is in copper, right? So 25 will be manganese, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d5. Let's talk. Okay, let's count. 5, 6, 4, 10, 12, 18, 20 and 25. Yeah, let's draw the orbitals of D. 1, 2, 3, 4. This, and this. So, right? Now, it's electronic configuration of iron, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Okay, now let's talk about iron. Then cobalt is there, I guess. Yes, cobalt. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7 will come here, right? Let's make the orbitals, right? 1, 2, 3, 4. This is the cobalt, right? Now let's talk about nickel, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. Let's make the orbitals, right? 1, 2, 3, 4. 5, 6, 7, 8, right? So now let's talk about the exception, which is in copper. So now let's talk about copper, whose atomic number is 29, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d. How many will come? I guess 9 will come. Let's count. 6, 7, 8, 9, 10, 11, 12, 12 plus 18, 20, 29. But this is the incorrect one. Like how? Let's find out. So the correct one will be 4s1, 3d10. Now I have told you that electron can easily move because there is a slightly difference in the energy, right? This is having 4 energy and this is having 5 energy, and this is only one number difference, so it can easily move. Now when we talk about this, it is like this, right? And this is like this. So this is stable because it is fully filled. Okay, but this is not. It is neither half filled or neither fully filled. So stability is not there, right? But when we talk about this, according to Hind's rule, we will fill one by one, right? So as you can see over here, this is half filled, which means it is stable, right? And this is fully filled, right? Means these both are stable. What we discussed previously, that stability only comes when either the subshell is half filled or fully filled, right? So as you can see over here stability is not coming, right? Because this is fully filled, but it is not fully filled, or not either it is half filled. But when we do this, it is half filled, means it is stability, right? There is stability. But when we talk about this is fully filled, it means there is stability. So now let's talk about that why this half filled and fully filled gives extra stability. Like why it gives extra stability? There are basically 3 reasons for that. Number first is there is symmetry. How it is symmetry, right? Let's talk about this. How there is symmetry. When I talk that it is half filled, right? This is symmetry, right? Because all are in one direction and they're half filled, right? When I talk about this, okay, so these are giving symmetry, right? So that's why, like, it's separate and this is separate, right? So that's why the subshell which gives symmetry is known as, will have stability, either it is half filled or fully filled. Second reason is exchange energy. The subshell with high high number of exchange energy will have high number of stability, right? For example, let's talk about, this is electron. Like, what is exchange? Like, we know that electron is a wave, like it is changing its position, right? So obviously it is changing its position, but there will be a transition of energy. That transition of energy is known as exchange energy. So wherever the number of exchange energy will be higher, so the stability will be also higher over that. And number third is smaller Coulombic repulsion energy, right? So these are the three main reasons that why half filled and fully filled are extra stable. So the most important one are these two, and this is asked sometimes. So I hope you understood the concept of electronic configuration, with the exceptions of chromium and copper.